Good morning. Can you hear me? I guess I better get one of these headphones. I won't hear myself. Can you hear me? Okay. Hi, can you hear me? Can people hear me? Yes? Okay. So my name is Michael Jones. I'm going to get us started. We're going to talk about sea space. I'm going to give a very presentation to kind of set this up. So if I can click this. So I'm really representing two different organizations. One is TMA Blue Tech, and the other is Subsea Sail. Let's see if I can get this to move. Oh, we go. Okay. So one of the reasons we wanted to do this particular panel is because things are changing with the ocean so quickly, and part of that is communications. So we have basically observation, and then we have communications. And both of those are incredibly important aspects for space observation. So we have two people here that will be speaking. One is Miguel Bello with the Air Center, and then it's Phil Mombay with the Pôle Bretagne Atlantique. Both are doing very interesting work. My goal is to give kind of an overview from our cluster and also from this company. So from observation, there are all kinds of things happening, whether it's finding and understanding where plastics are, combating IUU, identifying red tides. One area that we like a lot is this area of finding fresh water. I'll talk about that in a minute. And then there are constantly increasing numbers of observation applications. And then the area of communications at sea is really exploding with the advent of all the small sats. And Starlink has, I think, 10,000 satellites up with applications in for 20,000 new satellites. We're talking about really a proliferation in the ocean that will drive the price down really dramatically. And that will be for ships and crew at sea, for cruise ships. I can see Phil is getting cold and being blown away.
I will survive, I hope.
And then for maritime robotics, and our company, Subsea Sail, is one of those companies that is going to be using that communications at sea. So I'm not going to go through this whole slide, obviously, but one of the things that's really interesting to me is there are freshwater springs all around the world bubbling up in the ocean. And the easiest way to find those seas is from space. It's estimated that there may be as much as 10%, nobody knows, it could be more, 10% of the water that comes out of all the rivers of the world into the oceans is bubbling up under the ocean. And that is creating kill zones inside the ocean, strangely enough, because things that live in the salt don't like to live in fresh water. So the ability to use space assets to find fresh water is very important, particularly if you're an island nation. So in Hawaii a few years ago, they found several very prodigious, very large upwellings of fresh water right off of the coast. And it says there are few things on the island of Hawaii that are more valuable than fresh water. Plenty of rain, but the rain and many of these islands are volcanic in nature, and they're fractured so that the water will essentially run back into the ocean. And in some cases is creating benthic lakes underneath the benthic layer. Large lakes of fresh water. So if you're an island nation where it rains and yet you have too little water, space assets are one of the ways we can find those. And here we are at the United Nations Conference. We're talking about SIDS, these small industrial island developing states. One of their biggest problems is getting fresh water. Well, okay, we can give them desalination or they can buy desalination, but if we can help them find fresh water that they can harvest in some intelligent way, that's really the smartest things we can do, and it's where space assets can play a role. And so deep submarine freshwater, a new resource. These are articles from 2020, 2021. We've known about this for thousands of years. In the Mediterranean, there are places off of Lebanon, off of Portugal, off of Tunisia, where there are freshwater springs that are coming up. We need to know how to work with them, find them, and work with them. And so just some thoughts on freshwater. Identification from space is the fastest, most efficient way to find them, but then we need to work with people that can help us understand what's the best and highest use for that. Is it to create Fiji bottled water and sell it? Is it to have agriculture? Is it to reduce the cost of desalination? Or is it to use it in some direct other way? We have to make sure that whatever we use it for is to do no harm. It's got to be sustainable. Again, all I'm trying to give you is one example of observation from space that people weren't thinking about 5 and 10 years ago. These articles are, articles I've been looking for, but these are mostly 2020, 2021 kinds of articles. So now let me just say, the company that I co-founded with some partners, we make a unique kind of a long duration vessel. If you're out there in the ocean, once you go beyond line of sight, you're in the area of sea blindness. Well, we know that satellite communication is important, but right now it's very slow, unless you're the military and you pay for big bandwidth, and it's not everywhere, but it's quite slow and it's quite expensive. So what we are doing is watching and trying to figure out how we will take advantage of this revolution of communications coming from space. So our vessel, you can see here, it's a long duration vessel. You can see our water line is, we've got lots of patents, we've got funding, but at the end of the day, one of our limitations is that pipe, that space pipe. Now, one of the areas that people talk a lot about is combating IUU. A long duration vessel that has the ability to do acoustic monitoring and listening 50, 100 miles away when someone is coming, to provide a camera and communications. But if you're using 283 bits from Iridium, small message, you can't send a camera picture. And part of the issue is not finding these vessels, it's proving what they're doing. And so the photos become really important. And you don't want to find they were there 10 days ago or a month ago when you come back to port. So this idea of faster, accessible, affordable communications becomes more and more important as we see these problems. So we are developing new kinds of acoustic monitoring that will provide real-time beam forming. So we'll be able to look in certain directions, we'll be able to classify on board. It doesn't help very much to say, yep, somebody was there again 2 weeks ago or 3 weeks ago. We want to know right now. We want to know what they're doing. And so this communication becomes very important. This is something our vessels will be able to submerge as well, and so we'll be able to do things below the water and at the water line. But at the end of the day, you've got that little tiny pipe. Today, in our case, it's Iridium. It's expensive, and it's very thin. And in the future, this is what we're going to have. We're going to have mini pipes, and we're going to have much thicker pipes, so that we're going to be able to do applications that people need in a real-time basis. And with that, I would really like to go to the two people that are working with companies and new applications. Miguel Bello first from the Air Center, and I'm so impressed with the work they're doing. And then we're going to move to Phil Mombay to talk about some of the projects that the French and the European Space Agency and European Commission are working on. So next, Miguel, over to you.
Thank you, Michael.
Of course.
Good morning, everybody. It's a pleasure to be here. May we have the presentation? Well, my name is Miguel Bello. I'm the CEO of the Air Center, the Air Center, the Atlantic International Research Center. This is an international organization. It's a non-profit organization which was promoted by Portugal, but now a lot of countries are part of the Air Center. Our objective is to develop scientific and technological application in the area of the Atlantic towards sustainability, to analyze climate change, to deal with all the problems of the ocean. Our objective as well is in our network to create jobs in these domains. We are working with ocean, atmospheric and space sciences. And we work with companies, with universities, research centers and governments. Well, today we are, this is the number of countries which are already in the Air Center. We have in Africa, South Africa, Angola, Ghana, Morocco, Brazil, Colombia, Mexico, in America, and in Europe, Portugal, Spain, UK, Norway, and we are very proud that France is the last country to be member, and Paul Bretagne Atlantique is representing France in the Air Center. Our headquarters in the Azore Island, in Terceira, in Angra do Heroísmo, and we have also some offices in the Ministry of Science and Technology. The use of space for ocean is one of the main tasks of the Air Center. We do many other things in the ocean domain, but the application of space is one of the most important. That's why we are an ESA lab. ESA lab means it's a laboratory of the European Space Agency, which means we are part of the European Space Agency for those applications of space towards the ocean. This is our center in Azores, and we also receive data on our own antenna. You know, Michael said there are many, many satellites, but still there are gaps. There are many data that we need. We need to use all available satellites. We use the Sentinels, the European Copernicus program, which is one of the most ambitious Earth observation system, but also the American. We use NOAA, NASA, but even at the Chinese. I mean, in this antenna, we receive up to 24 passes per day, giving our data, real-time data, all the North Atlantic. We also have our own satellites. There is a new Portuguese satellite operator. Those are the first two Portuguese satellites, and we got about 10% of this system so that we can use very high resolution data for our projects. The satellite on the left, it gives 20-meter resolution, but with a swath of 650 kilometers, we get full countries, which is very nice to cover full ocean regions. We can get 1 million square kilometers in single images. And on the right is a very high resolution, 42 centimeters. That means for the coastal areas, we can go to a level of the 40 centimeter resolution when we want to make analysis of coastal incidents. Well, what are we doing? Well, this is quite useful for disaster monitoring. We have today with us Joaquin from La Palma. You know, La Palma Island has been very much affected by volcanic eruption. Michael said most of the islands on the ocean are volcanic, and we have to monitor volcanic eruption because it affects the ocean. Then this is a real-time 42 centimeter resolution of all the new region of the volcanic eruptions on La Palma, for instance, with GeoSat satellites. But also pollution. There are plastic pollution, but there also natural pollution. This is how we monitor another Canary island. This is El Hierro Island. You can see there was an underwater volcanic eruptions with lava, this is a pollution which is natural pollution, but you have to prevent fisheries to be done in this region. You have to prevent swimming in the beaches. This is other type of contamination. This is human contamination. This is the coast of Africa on the left. You can see that there are some contamination from direct water which is put onto the ocean, but we don't have to go to Africa. This is Malaga. You see that Malaga sometimes again had this problem of contamination on the coast, which is also artificial. And yes, also the quality of the water is important, but also the quality of the air. This is, for instance, air quality in Madeira and Azores. But as I said before, for disaster monitoring in the coast, satellites is the best tool to mitigate it. This was, for instance, the tsunami in Japan, the very large tsunami which happened several years ago. The very first satellite taking images is the one you say, it's just the GeoSat-1. And you can see the image of the satellite that this is on the left before it was a valley, an agricultural valley, and it was a fjord with the water entering 14 kilometers. This image is taken a few minutes after the accident. What that means that you can organize all the relief. You can know which highways, which roads, which are available to really get help support to the population in the coast. But also Fukushima. The very first image of Fukushima with problem was by satellite. Then only a few minutes after that, we can see Fukushima that all the protection was completely destroyed and the water entered within the Fukushima nuclear power. That means this is very helpful for coastal analysis. And this is, for instance, Maspalomas, where we have to analyze which is the effect on the coast on a natural park, a beautiful natural park in Canarias. But sea level rise is monitored by satellites. This is Bora Bora, which is a paradise today, but we don't know for how long we can keep this paradise. Then we do a continuous monitoring of sea level rise like those type of images. There are other type of problems, apart from pollution, apart from sea level rise, which is piracy. And we are concerned of all type of problem on the ocean, and piracy is another problem on the ocean. This is the Indic Ocean. Those are 3 small boats of pirates waiting for a big vessel to hijack. Then this can be monitored by satellite. You can see where they are, which is the behavior, and how you can fight against piracy also by satellite. And you can see also there an important thing is how the pirates get into the ocean and get out of the ocean. This is also done by satellite, because if you get the infrared data, near infrared, you see which roads are used and which not. The ones which are not used create chlorophyll. Then you get a signal in the chlorophyll in the near infrared. Then we can tell also which is the way pirates use to get in and out of the oceans. Also illegal traffic. You have narco traffic, you have smuggling, you have illegal vessels, you have illegal immigration. This is not a problem in the ocean. This is one of the hot places in the world, which is the Gibraltar Strait. You can detect by satellite, you can get an image, which is an optical image, and combined with AES. Those vessels which are not identified, those are subject to potential illegal traffic, which is also another problem in our oceans. We firmly believe that we need data for the ocean, but this data has to be combined with artificial intelligence, with blockchain. In fact, artificial intelligence with a big amount of data, they cannot give the proper result. Then we have short video how we believe that the combination of Earth observation data from space for the ocean together with artificial intelligence, but also with in situ data. We also need data from the water column. We need gliders. We need also radar, because satellite by itself can only see the surface. We also need to complement with the water column. This is a small video, 2-minute video, which shows. I hope you can hear it.
Coastal zones are of paramount importance for European citizens because they include 40% of European population. The total value of the services produced by marine and coastal ecosystems is valued at 29 trillion euros per year. But serious problems are affecting our coastal areas and maritime zones. Coastal pollution and plastic in the oceans, illegal fishing, natural hazards due to climate change, sea level rise, piracy, illegal traffic, smuggling, loss of biodiversity. We need new tools to help governments and policymakers to face those challenges. We need the direct engagement of citizens. The observation of the Earth from the space offers a synoptic view of our oceans and coastal zones. The combination of Earth observation with artificial intelligence algorithms and blockchain in decentralized digital networks provides a unique tool to mitigate many of the problems we are facing today. Ocean pollution can be tracked and identified by satellite. Ocean natural hazards are mitigated by EO and AI techniques. Illegal traffic and illegal fishing is identified with optical and radar images and machine learning algorithms. Volcanic eruptions are monitored by satellites. Coastal erosion and sea level rise can be predicted and mitigated. The Atlantic International Research Center, AIR Center, is an international organization devoted to develop scientific and technological applications in the Atlantic. Act now for future generations.
Well, this is our view, to combine the Earth observation data with the in situ data with artificial intelligence is what can help us to mitigate those issues. Which is the next steps? Next steps on the space data from the ocean. We have gap. It's very frequent data every hour, every 2 hours. For this, on the Gnss Center, we promote a constellation called the Atlantic Constellation. It's a constellation of 16 satellites. Well, it's a constellation of 16 satellites which will give data with very high frequency, complementing the Copernicus and NASA and NOAA satellites. The idea is to have together first an Internet of Things transponder. As Michael said, we have more and more data to get data from mammal stacks, for aquaculture centers. Also, we will have an AES identification of vessels and multispectral and hyperspectral cameras for alga bloom, for ocean color, for ocean temperature. All this with a very new sensor. Is Gnss Reflectometry. This is a very new sensor for the ocean. It's a sensor which takes a direct signal from Galileo or GPS and the signal reflected on the sea. By taking the difference of two signals, we get wave altitude, we get wind, we get many sea parameters. It's a very new type of tool, which is very much led by Portugal and Spain in Europe, but the States already did a test for that. That means we will put that in this constellation. This constellation is now signed by Spain and Portugal the first 16 satellites. All the countries of the ES Center are joining. South Africa recently, last week, expressed the intention to join the constellation. United Kingdom already did a feasibility analysis. We're waiting for the decision. Another country that going to join the constellation is Brazil, INPE, it's the Instituto Nacional de Pesquisas Espaciais. It is Mexico, it's Nigeria, and Norway. Well, this is basically the conclusion. I mean, Earth data combined with artificial intelligence, combined with in-situ data is what we need to mitigate this problem. Thank you.
Thank you very much. My presentation will be a bit more boring. Less picture. Sorry, I'm cold. Sorry. So I'm Phil Morbet. I'm from the Sea Innovation Cluster. If you had a chance to be here this morning, they explained what a cluster is. And so I'm not going to start that again. But just to let you know that inside our membership, we used to deal with space since 2 or 3 years, or maybe 5 now, a bit more, because you realize today that in any activities of the blue economy, you will have to use satellite data. Satellite data can give you 3 main things. It has been said, Earth observation is like you can watch from space what's going on the sea. It gives you your position on the sea. There's no infrastructure, no facilities in the sea, so you need to be where you are and where you go. And it gives you, as Michael said, communication. And that's really important in the sea. You need to be able to communicate. So our French government decided to have a good idea, bringing an initiative called Booster. It was led by our French Space Agency and 3 main ministers, Education and Innovation, Armed Force Ministry, and Economy and Finance. Because, as I said, satellite data and satellite technologies are strategic, especially on the ocean, but in basically all domains of the economy. And in France, we have a high asset because we are manufacturing satellite. We have 2 main companies, Airbus Defense Space and Thales Aliena Space. We're ranking second, not first, probably USA first, maybe Chinese now, I'm not sure, but USA probably still first. And but basically for years, we built satellite mainly for military purposes, but we didn't do anything with them. It's like to be honest, that's. And so this French initiative is just to create some small entities I'm going to talk about to promote the use of satellite data and technologies for the development of new products and services. And so that's where we were born. So basically we built small consortia consortium inside our cluster, bringing together stakeholders or key entities from space, key entities from IT, because when you deal with space, you deal with a lot of digital technologies and applicative sectors. So in France, we set up 7 boosters, but one is dedicated to the sea, and that's ours, which called More Space. It's quite obvious, More Space, but in our native language in Brittany, More means sea, and espace in French it means space. So basically, that's all the boosters that were created in France. We're based in the western part of France, but we also have different other type of booster. We are the only one to be dedicated to the sea. The other ones that are dedicated to mobility, agriculture, and so on. What do we do? We actually set up, as I said, you can find satellite in every fields of the blue economy, but we try to streamline this and put that in our strategic roadmap. And we basically did with all the satellite data and technologies that deals with the energy, and especially marine renewable energy with offshore floating wind. Risk management, you mentioned the coastline and the tsunami and stuff like this. Safety and security at sea. This morning we talk about e-navigation, and autonomous ships, resource management, illegal fishing, you mentioned it too, and environmental monitoring with water color. What do we do for our members? We sort of be like a small cluster within a bigger cluster. We do a lot of representation. Copernicus was mentioned this morning. It's the Earth observation program from the Commission. We are Copernicus Relay and Academy. We used to be a member of two good or important associations at the European level, which called Nereus and EASC. We do some lobby. We organize some events. We talk about satellite and space, like I do today. We do a dedicated newsletter that combines space and maritime. And we try to offer some opportunities to our members. It's funding, it's trade show visibility, infrastructure accesses with the ESA, the European Space Agency, or French Space Agency. For the last 5 years, we support more than 30 projects for a total budget of 14 million, and we help to secure our members more than 3 million euros. You will tell me it weighs not much in the blue economy, but still the satellite data and technology is still a market niche, and we need to work and support these companies. That's all on my side, and I will be happy to answer some questions if you have some.
Thank you, Phil. So I just want you to know that if China's taken over, you're number 3.
Okay. Baga. The Australian said baga.
So, although he said it was going to be boring, I found what the French are doing really amazing, and what Air Center is doing is amazing, and that's one of the reasons it's so fun to have this opportunity. So what I'd like to do, I'm going to ask a couple of questions, but I'd love to hear questions from the audience, so let's don't wait until later. So I think the young lady's got a microphone, so anybody with a question, let us know. So let me ask both of you, so the French opportunity, how does a company in the audience, how does a Norwegian company work with the Polymer to do something in France? Because you're doing some really cool stuff, and then the same thing for the Air Center. How does a company, not a country at the moment, work? So first with you, Phil.
We tried, I visited over already, and that's something, they have a huge company called Kongsberg that do a lot of things within this area, and the best we can do is to make sure that we exchange information quite frequently when there is some opportunities. In the past there was, and there is still some European Space Agency call, and so we try to talk to each other and to just make sure that we can share the information and have the chance to apply for application, call of tender, and things like this.
So we have a member company that is doing non-jammable GPS. It's like 100 times more powerful than normal GPS. It's a venture-backed company. Could we introduce them to you, and you guys can work together? Yeah.
Yeah. I will actually just asking my members what do they need, or if they need some positioning of if they have positioning issues and stuff like this. I'll be happy to put them in contact and to try to help them to access our membership. Yeah.
Perfect. That's what the BTCA should be doing, right? Yeah. Okay. So over to you, Miguel. So how does a company work with the Air Center?
Well, it's a similar way as it is what we do is teams for projects. Then, well, now we are opening our data center, and we will give data to universities and companies that they can receive data from us.
So this is a 24/7 center.
Yes, this 24/7 where we receive real-time data. Then we want to all the countries which are members of the Air Center, companies within those countries, they request data. We can give data. We're going to feed a kind of ecosystem of companies doing application on the data. But apart from that, we do teams for particular projects. Okay. As God said, it is a call for tender of the European Space Agency or Horizon Europe. Then we create a team and we bid for that. we are not competing with the industry or with the university. We do teams. I mean, an example, there was a big competition for ports of the future. It's a project of the European Space Agency to define clean ports, which are non-contaminated. And then we create a consortia with a company in New York, with a company in Azores Island, with Inestec, which is a research center in Porto, together with the governmental bodies, together Port of Azores, which is a governmental body. Then we make a team with industry, academia, and governments. And we were successful. We won this bid. We are now running this project. I mean, it's a competition. It's difficult because there's a single winner. In the European Union, there may be several winners, but this is the type of thing we do with companies.
That sounds very interesting. I see that we have a question.
Yeah, hi. My name is Steve Adler. I'm from the Ocean Data Alliance, and this is a question for Air Center, for Miguel. I saw from your presentation that you are using AI to infer different aspects about coastal environments because the satellite coverage is still sparse and you don't have any sensors in the water, and putting sensors in the water is very expensive. So the question is a little bit technical. What I wanted to know is what density of, because sensors in the water are expensive, it's hard to put them in the ocean, there's very little coastal observation. So what density of coastal observation is required to match the fidelity of the satellite instrumentation? Like, you can't put hundreds along the coast, say, in the Mediterranean, Spain. So, but what density? Have you figured that out?
Well, that's a difficult problem question because it depends very much on the type of problem that you want to solve. There is a minimum number, which is because satellite has to be calibrated. Then you need a minimum number of satellites to C2 data to calibrate the satellite. At the end, you get signals in different wavebands, but you have to correlate with the measurements. Then there is a minimum number, which is in every location, you need to have one calibrating sensors. Then depend on the problem. There are other problems that you need a lot of them. For instance, we have a project with the Luso-American Association, which is going to put sensors on the coast every few kilometers. That means there will be, we want to cover, have a country coverage. Then there will be, at the end, will be hundreds of sensors. Depending on the problem, the number changes very much. In fact, what we said about artificial intelligence is what we do a small thing, because what we don't is the people in our network to do that. We want to give the data so that companies and universities are developing it, because we have a limited capacity of doing this. What we want is somehow to be an enable so that other players can develop it and use our database to do the applications.
And then you use the satellites offshore to geolocate, use the sensors offshore to geolocate the satellite when you can't see land? Is that what you do?
Well, wherever we see some land, then we use normal orthoratification. We don't need a sensor. On the sea side, normally we have to depend on the attitude and orbit control system precision of the satellite. Otherwise, it's quite complex to get it. Thank you.
Yeah, let me just make an observation that Ove, the microphone is coming. They're obviously, Air Center is part of the ARC system as well. And one of the reasons that we are all working together is so that we can get more fidelity and more overlap from the space with what's going on at the ocean level, both above and below the ocean. So these are really interesting issues. The last panel talked a bit about this, and part of what we're trying to do, both the company I'm involved with, but others, is drive the price of equipment down on and below the ocean. So we'll be able to do a lot more ground testing or water testing, ocean testing, if you will, alongside the satellite. So there's a lot going on in this whole arena. Ove.
Yeah, thank you, Michael. Yeah, just also maybe a bit technical question, but we have been doing some work on using AS sensors in the same way. Quite advanced radar systems, dual polarimetric radars, to identify or detect small objects in the sea, even moving objects, also together with the infrared. Is that something you look upon as maybe could be integrated also as a sort of sensors feeding your system with data?
That's a very good question. And in fact, this is the case. I mean, the idea is to have 4 levels of data. It is a water column, this is gliders, surface data, airspace, but you have to fill with atmospheric data, with air data. For air data, it's not only drones. I mean, We are now testing together with Inestec, is a Portuguese institution, is a Portuguese research center. We're testing a hyperspectral camera to detect plastics from drones. But we believe that HAPS, maybe even better. HAPS is a high altitude platform. You know, they fly at 20, 30 kilometer altitude, and they have very big area where they can be standing over covering a continually big region. I mean, the advantage of the satellite with respect to the drone is the huge coverage, but the question is that it flies at 30,000 kilometers per hour. Then it goes so fast. Then HAPS is a perfect combination. Then drones, HAPS, and satellites, the three must be used and combined.
Come on, audience, we need these questions. So somebody's got a question, all right? Would you stand up and introduce yourself?
Hi, my name is Rani Al-Sharif. I'm half Jordanian, half Dutch. But I have many questions. Just a moment. I have questions here.
We'll let you have one.
What about GDPR standards?
Out of scope.
No.
Out of scope.
Out of scope. Not necessary. Privacy.
Yeah, no, that's a good question. We at least for the project we support, we are more on the environmental side, or it depends. There's so much application. No, but for privacy, maybe the example of illegal fishing. We are supporting projects that supposed to be in line with the law.
Yes,
so it's not a question of privacy here. We do not support as a cluster. We do not support a project that deals with individuals.
Under EU regulation.
Yeah.
This question is very relevant. The question is, you have a line which is called the Kármán line. The Kármán line is about 100 kilometer altitude. If you flow above the Kármán line and you are over a country, you are not in the space of this country, then you can take pictures. There is no limitation. You can take whatever you want. But what you do with the picture, this is something subject to the law. Then every country have a given regulation. This is called shutter control. US is the first country which put that shutter control. Then shutter control, it is a very important thing. Then US company cannot sell this image, cannot do unless it has a clearance from that country. Then
what about SpaceX?
Yeah, that's what will change. That's what we call the new space. I mean, part of the value chain of new space. It will change, and it's already started. Let's say that to simplify, like a few decades ago, we had only a few satellites here and there, and now with SpaceX and other new launch system, we're gonna have plenty of small satellites watching or observing, I should say, monitoring and doing a lot of things. Yeah, we completely changing the way we do things today.
And the price.
And the price too, yeah, of course. It's.
I'd like to ask you guys about the price. I mean, Miguel, as you see the small sat revolution, how do you expect that's going to impact your costs? You know, the ability to gather information.
Well, as has been said, it drastically changed. I mean, to make an Gnss satellite 20 years ago was impossible to do it for less than 100 million. Now with 1 million, you do a satellite, you launch it, and you operate it. The prices drop down by 2 order of magnitudes.
Right.
Then that drastically changed the scope, and that's why there are so many players. That's why now it is a proliferation. But this is something which has to be controlled, because on the other side we have the problem of space debris and flight the space. This is a serious problem. We are working hardly on the space debris. Our satellite has to maneuver to avoid collisions every few weeks. And
really?
I mean, we have a lot of people just looking to the next 15 days. You are going to cross some of the 25,000 objects that we have in the records. There are about 1 million objects that we don't see because they're too small. That we see, which is more than 5 centimeters, there is about 30,000 objects. Then we have to take into account also this, because there will be a limit on the exploration of the space.
So, Federico,
Okay.
go ahead.
Frederico Ferreira from Fórum Oceano, Portuguese Economic Cluster. I want to ask a question maybe to Miguel and to Phil and to you also, but because of the opportunity there will be the interface C space in the submarine cables, and how you see, for instance, the use of sensors that you talked on the cables to monitoring and to interface with the space. If you think this is something that could be done or not, and if it's interesting opportunity for Portugal, since we have the confluence of several submarine cables, one in Madeira, other in Sines. So how do you see that?
Well, there is a project at the Center where we are part of a project with other Portuguese and Norwegian institutions to put sensor on submarine cables. It is a project we started last year, and that is very promising. We really believe that we can get a lot of information putting that sensor in the submarine. I think that's when I said water column, I should also include submarine cable. Thank you very much.
Question over here. Could you hand the microphone?
Yes, thank you, and good morning, everyone. I'm Jerry Miller from Science for Decisions. I've had the pleasure of being engaged with the Air Center off and on for a few years, so I know a little bit about their emerging space-based capability. I'm excited to hear about similar efforts evolving elsewhere. But Michael, I want to turn to your comments about advances in situ measurements that will then make our satellite-based observations more valuable. I'd like to hear from the three of you, what are the 2 or 3 most important in situ observations that you need in order to gain most value from your space-based observations? And of course, I'm thinking about the fact that we already have some deep ocean profiling floats, for instance. We have emerging capabilities of the sort that you talked about, Michael. But with respect to the sensors, what should they measure to help you extract more value from the space-based observations?
I might start. I think the classic ones, temperature, salinity, and chlorophy or fluorimetry, I should say. If we can get more of them, it's a matter of resolution for them to increase, but from my former life of biogeochemist, I would say nutrients, nitrate, phosphate, and carbon would be the one that we mostly need to improve our understanding of how the ocean functions. But it's more in terms of environmental view.
Well, apart from those said by Phil, I would say glider for the column water and hubs to have a constant view, which is instantaneous, is not just passing. That will be the 2 sensors in addition to the one that Phil said.
I was more talking about parameters. I don't know if your question was more on parameters or the vectors themselves, but.
So
there's one more question back here.
Hold on. So we're probably more focused on situational awareness. So MDA, if you will. The long-term measurement, which is what I think they're talking about, and periodic measurement, obviously, is very important, particularly if you're trying to continue calibration. And a long-term vessel, a long-duration vessel, long residence vessel, can do that. But often, what people need immediately is there is a boat here, and that boat is a drug runner from Colombia, and I need to know right now. And so the communications effort is, if you're out in the ocean, you can pick up the data and bring it back and give it to somebody, and they can analyze it. But often what they need is there are right wheels right here, so I can tell boats to slow down and not hit them out of Boston Harbor. And so I think there's a difference between long-duration monitoring and how immediate you might need to provide that information. And we are more focused on monitoring, but then exception-based reporting at the moment you need that exception-based reporting. So the communication side is the most important for me. We provide information for observation for others. So I think there's really temporal differences as to what we're trying to do at a given time. There is another question in the back.
Yeah, this is Eric Siegel from Ocean Frontier Institute. Jerry, that was a very, very good question. And I want to try to build on that a little bit, which is that climate is at the top of everyone's radar here. And climate really means air-sea interaction and carbon absorption in the ocean. So what does the future of space observation look like for the air-sea interaction, for carbon monitoring, and what do we need to do at the ocean surface and below to help enable better satellite observations of that?
Very good question. I don't have a proper answer to that. It's really I'm not sure. I'm not sure I can answer that. It's quite complex. What is changing is we're gonna have more and more data that will help us to probably develop and better model that could help us to better understand. It's not really on my side. It's I'm more used to support projects that help to fight against illegal fishing, monitoring vessels, and but I'm not sure. I'm sorry. I can't really answer the question.
Well, perhaps Miguel can.
Yeah.
Well, it's a difficult question. I mean, on the land, we are now at the Air Center promoting a carbon mapping mission to monitor, which can help us very much, or for biomass can help us very much for the, even for fires, which is a problem which in the Mediterranean region fires is a very big problem. And we have to extrapolate that to the ocean, which is different. The type of sensor, the type that to get this information from the ocean is quite complex. But it's not easy, the answer to this.
Maybe what I had is there's a lot of discussion at the national and European level on different payload we can put on the next Sentinel and in the Copernicus program, and climate change and carbon is a main focus. So there are some discussion between scientific and the people who's dealing with the payload. So I'm sure there will be some change. It's not like a short-term change, but in a longer term, like 2030 or something like this, there will be things implemented to better understand and better monitor all the carbon issues.
I'm sorry. I think we have to. Do we have to stop this point? Yeah. So I'm getting the nod here. I just want to say that this is a fascinating topic, and I hope you'll take advantage of the expertise of these gentlemen. As always, you know, we're partners in various ways through Air Center, through the Blue Tech Cluster Alliance. This is an area that we will continue to work on, and technology is moving so rapidly in space and in the ocean right now. We will find more and more ways to work together and help each other.
Yeah. Long life to BTCA.
Yes, long life to BTCA. So with that, I'm going to call it but I do want to ask who didn't pay the heating bill. I always heard that Portugal was a warm country, and you know, I'm coming from San Diego. It's a little bit warmer than here, and I'm freezing. And I'm looking at Phil, and he's going like this. Thank you for all sitting here with us, and we look forward to talking with you in the future.